we can go ahead and reboot. Hehe, that does work. Hi everyone, and welcome to episode 5 of DOSing with MAME. Today we're going to install FreeDOS on an IBM 5150, which is being emulated in MAME. So this episode was inspired by a TechTangents episode from earlier this year, where he prepared a specially crafted version of FreeDOS, which can be installed on an IBM PC or XT. He describes in his video all of the trouble that he went through in doing the initial installation. And as a result of all of his trials and tribulations, he actually created his own mini distribution of FreeDOS for 8086, which he calls FreeDOS 1.3 8086 Minimized. This can be found on archive.org. I will make sure to provide the link to this so that you can download it yourself. In his video, he describes everything he went through to prepare this mini distribution, and he does go over the basics of how to install it, but he doesn't show every single detail. So for this video, I had to actually try it and make sure that everything worked and get it all perfected. So to start out with, the first step is you do the basic installation of the base operating system on your hard drive. Then there is a second step where we will install the optional extras, which are things that if you are a DOS user, you probably want those things on your system. So let's talk about the basic MAME setup, which is required to do the installation. It's pretty simple. The 5150 in MAME obviously comes with a floppy controller, which you put the provided disk image in, and you also need a hard drive, which you want to install on. So these are the basic options that you need to provide to MAME in order to perform this install. So the full command line demo that we're going to go over is you create the hard drive image, and as I described in my previous video about creating hard drives for MAME, you'll have to use a 20 megabyte hard disk with 615 cylinders, 4 heads, and 17 sectors. So you create exactly that hard drive image, and then you run MAME, you put in the floppy, you put in the hard drive, and you're ready to go. So now I'm going to show this procedure in action. As I said a few moments ago, the first thing that we need to do is we need to create the hard drive image. So here's our chdman command again, and now we're going to run this command, and you can see that it created exactly the hard drive image that we need: 615 cylinders, 4 heads, 17 sectors, and it's 21 megabytes. So now with this hard drive image, we run MAME, providing the disk image for the installation and the hard drive image. So let's go ahead and run this. And we will wait for it to boot, of course, which, as I showed in my previous video, takes about 1 minute. So now that this is booted up, the instructions are printed right here on the screen. Partition with fdisk, format, make it bootable with a sys command, and then run setup. So let's go ahead and get started with this process. First we run fdisk. And we just say yes to FAT32 support, create the partition, create a primary partition. Do you wish to use the entire drive? Yes. And it creates a 20 megabyte. In this case, it's FAT16, but the partition is created. So now we're done in fdisk, and we must restart. Okay, restarting, and wait for it to boot again. Now we continue on with step 2. Formatting is done. Now step 3, make it bootable. As he mentioned in the video, there is an error here where it tried to find command.com on the A drive, but it found it in the FreeDOS directory instead. This is fine. System transferred. So the last step is to call setup, which basically creates directories, copies files, yada yada. Now it's asking us to insert disk 2 and press enter to continue. So let's go ahead into MAME and switch this to disk 2. Read only should be fine. Okay, now the base install is finished. And we need to remember that in order to continue the installation, to install the additional files, we need to consult the file FreeDOS bin zm help.txt, because we're going to have to reconfigure MAME and then come back to this. The way that it is recommended to do this is to use a serial port. So if you were using real hardware, I have shown a laptop and USB serial port here, you would take your IBM computer and you would connect the COM port through a cable into your USB adapter into your real computer. And then you would run some software, either Minicom or Teraterm, in order to do that transfer. But because we're doing this in MAME, we have to do things a little bit differently. So here we've got the MAME emulation, which is running FreeDOS. Note that the floppy drive has been removed. We have done the basic installation, so we can now boot from the hard drive image without it. So, as I described in a previous video, the hardware that's in this machine includes a dual port asynchronous communications adapter. And so, since it's dual ports, that means that we have COM1 and COM2. For this demo, we're going to use COM2. And the way that you configure that port is by using the command line that we have shown here. The communication board is in ISA slot 2, and that has two communication ports, serial port 0 and serial port 1, corresponding to COM1 and COM2. So what we're doing with this command is we're telling COM2 that we want it to connect to a null modem cable, just like we would need to if we were using real hardware. You would probably need to use a null modem cable of some sort. We're doing exactly the same thing here in MAME. So now that we have the null modem, we need to actually attach it to something. And MAME provides what's called a bit banger. This is not in the actual emulated computer. This is on the MAME side. As you're running MAME emulation on some computer, it's running over there. What the bit banger does is it sends and receives data to the COM port. Right? The COM port has a UART. It could be, I don't know if it's exactly 8250, 16450, 16550, but you have a UART in the emulation on this communications adapter. And so the bit banger talks to it. It actually looks at the bits that are going across. And so you can connect this to one of two things. You can connect it to a Unix domain socket, which will work on Linux or Mac OS, potentially on Windows, but I don't think it's a normal thing. But Linux or Mac OS definitely have domain sockets, which you refer to by a file name on the file system, domain, and in this case, we're using temp IBM 5150. So now that you have the MAME side completed, you have the emulated computer with the communications adapter connected to a null modem, connected to the bit banger. The bit banger is going to a Unix domain socket, and usually on Linux or Mac OS, you can run Minicom, and Minicom knows how to talk over Unix domain sockets. So that's what we're going to demonstrate. In review, here's the command line. We have our 5150 emulation. We have the previously created hard drive image. COM2 is connected to a null modem adapter. That null modem adapter is connected to the bit banger. The bit banger is going to the Unix domain socket. And then on the Minicom side, we tell it, yep, I want to connect to this Unix domain socket. So now we are going to demonstrate this. So here's the command line that we're going to use to demonstrate using a Unix domain socket to communicate in between MAME and Minicom. So the first thing that we need to do is, if there is an already existing socket, which a socket appears as a file on the file system, we need to go ahead and remove that first so that MAME can create a new one. So we just delete that, and then we run MAME with our IBM 5150 emulation. We attach the hard drive to it. We tell COM2 to connect to a null modem, and then we connect the bit banger to the Unix domain socket. So this is the MAME end of things. Let's go ahead and run this. All right, so MAME is going to take a while to boot up, but the socket should already be there, so we can actually start up the second side of it. So on the Minicom side, what we do is we tell Minicom connect to this Unix domain socket, and if we run this, it should start up and connect and just be sitting there waiting and ready for us to do something. So we'll come back when the emulation in MAME has finished booting up. So now that MAME has been booted up, we need to remember the instructions that were at the end of the installation. There's a file, FreeDOS bin cm help.txt. So these are the instructions on how to actually do the file transfer. So there's a couple of things that we need to do here. We need to configure the MAME side to make sure that the COM port settings are all correct. He's recommending using 9600 baud, but we can actually do a little bit higher. So let's go ahead and do the MAME configuration. So we do want to use flow control, RTS flow control actually, but we want to set the baud rate here at 19200. So you want RTS, 8 data bits, no parity, 19200, 1 stop bit, and 19200. So these are the serial port settings that we need. Let's go ahead and start transferring some files. First, we want these files to go in the FreeDOS bin directory. They refer to the help file. And we're going to make the modifications that we need to. CM, COM2, 19200. We want RTS. Okay, so this is a command that we're going to run on the 5150 side. Now, in Minicom, I'm going to type Option S to get the send menu. On a Mac, usually Option is also the meta key. So that's how you bring up this particular menu. We want to do zmodem send. We want to select all of the files in this FreeDOS additional bin directory, which is in the zip file. So we just select all of these. There we go. And we say, let's start the sender first. Okay, the sender is running. Now we start the receiver. And these two guys should start transferring files. And looks like they're off. This is going to be a little bit faster than the original demo at 9600. I don't know if you can really do 19200 on real hardware, but apparently in MAME we can, so why not? Okay, we'll come back when the file transfers are finished. All right, just about to finish. Okay, so now I have successfully transferred all of the files into the FreeDOS bin directory, and this installation is complete. And you can enjoy using FreeDOS in your emulated IBM 5150. We just demonstrated using a Unix domain socket, which should work on Linux and Mac OS. What if you're doing this on Windows? There's another thing that you can do with the bitbanger. The bitbanger can connect to a TCP/IP socket. And this, of course, works on all the operating systems, but it's especially important if you're trying to do this procedure on Windows. So instead of saying domain, you say socket, the host name, and the port. So MAME will listen on a port and wait for something to connect to it. This is extremely convenient because we can use a piece of software such as Terraterm. We can configure Terraterm to connect to the socket, which connects into the emulation. So this is what we're going to demonstrate. So to review here, we have the MAME 5150 emulation with the hard drive attached. We have COM2 connected to a null modem adapter. The null modem adapter is connected to a bitbanger, and that bitbanger is listening on a TCP/IP socket. All we have to do is run Terraterm and tell it to connect to this socket, and the two things should be able to talk to each other. All right, I'm going to go ahead and demonstrate this. Now we're going to demonstrate the socket version using a TCP/IP socket. So we have the command line here again. We're running MAME with 5150 emulation. We have the hard drive image, and we have COM2 is connecting into a null modem, and that null modem is connected to a TCP/IP socket. So we'll go ahead and run this. All right, the socket should be open. So the only thing that's left to do now is we need to start up the terminal program. And in this case, we are going to be using Teraterm. I'm using Crossover Office, which allows you to run Windows software on a Mac. So we'll go ahead and run Teraterm. If it's set to TCP/IP mode, we want to do localhost. And we need to say other. It's not Telnet and it's not SSH. And the port number is 65504. So if we do this, Teraterm is now connected. And we can do the same thing that we did on the Mac side. So type FreeDOS bin zm help.txt. So let's double check the MAME settings before we continue with this. The instructions here say to use 9600 baud, but in MAME we can actually use 19200 baud. So the serial port settings we need to have, flow control needs to be RTS, 8 data bits, no parity, 19200 baud receive, 1 stop bit, 19200 baud transmit. Okay, so let's get the command ready to go. ZM COM2 19200 baud with RTS, and we need to receive the modem. So our receive command is ready to go. Let's get ready to send files on the Teraterm side. So we go to transfer, zmodem, send, and then we have to navigate to place where we have our files. Temp, IBM 5150, FreeDOS minimized, and the files we need are in FreeDOS additional bin. And we just select everything here. Oh, that's everything. And we need to make sure this is binary is checked. And we say open, and the send side is waiting. And we start zmodem on the receive side. And it should take off and start transferring. There it goes. So the rest of this is exactly the same as we had on the Linux side. Alright, so we've successfully installed FreeDOS, minimized in IBM 5150 emulation running in MAME. So that was what I wanted to show in this video. Bye everyone.